Good day, students. I still remain your online mathematics teacher, Mr. Ochilon C. If you have not subscribed to my channel, you should do so that you can have access to other lessons. The topic we are considering today is factorization of algebraic expressions. Factorization of algebraic expressions. Before you can factorize algebraic expressions, you should know what factors are all about. Factors. The factors of an algebraic term are all terms that can divide into it. Example 1. Find the factors of a, 8xy, b, 3ab squared. Solutions. A, 8xy. We're starting with the numerical terms. The numerical terms of 8xy are 1, 2, 4, and 8. Terms in x. X, 2x, 4x, 8x. Terms in y, 2y, 4y, 8y. Terms in xy, 2xy, 4xy, 8xy. Therefore, the factors of 8xy are 1, 2, 4, 8, x, 2s, 4s, 8x, y, 2y, 4y, 8y, xy, 2xy, 4xy, 8xy. B. 3ab squared. The numerical terms are 1 and 3. Terms in A and 3a. Terms in B and 3b. Terms in B squared and 3b squared. Then terms in AB, 3ab. They will now have terms in AB squared, and 3ab squared. Therefore, the factors of 3ab squared are 1, 3, a, 3a, b, 3b, b squared, 3b squared, ab, 3ab, ab squared, and 3ab squared. The next is highest common factor, HCF of algebraic expressions. The highest common factors of algebraic expressions is the highest or the largest term that can divide the algebraic expressions without a remainder. Example 2. Find the HCF of 14pq squared and the 20p squared q. Here, solution. 14pq squared. For us to get the factors of 14pq squared, we need to divide with factors, starting with the least factor. The least factor here is 2. If we divide by 2, we have 7pq squared. We now divide again with 7. We have pq squared. We now divide with p, we have q squared. We now divide with q, we have q. We divide with q, we have 1. So the factors are 2 times 7 times p times q and times q. The next is 20p squared q. We start dividing with the least factor, which is 2. 2 divide 20p squared q, we have 10p squared q. We divide again by 2, we have 5p squared q. We divide again by 5, we have p squared q. We now divide by p, we have pq. We now divide by p, we have q. We divide by q, we have 1. So the factors are 2 times 5 times p and times q. The highest product factors found in both expressions is 2 times p times q, which is equal to 2p. Therefore, the 2pq is the highest common factor of 14pq squared and 20p squared q. The next is lowest common multiple of algebraic expressions. The lowest common multiple of algebraic expressions is the least term that is a multiple of the algebraic expressions. The least term that is a multiple of the algebraic expressions. Now we have example 3. Find the LCM of 9s and 15s squared. We still do the same thing here. We have to start dividing with the least factor. So for 9x, we have 3. 3 divide 9x will give us 3x. We divide again with 3, we have x. We now divide with s, we have 1. So the factors are 3 times s, which is equal to 3 raised to the power 2. That is 3 into 2 is 3 raised to the power 2 times x. We go to 15. We start dividing with the least factor. We have 3 divide 15s squared, we have 5s squared. We divide by 5, we have s squared. We divide by x, we have x. We now divide by x, we have 1. So the factors are 3 times 5 times s times x, which is equal to 3 raised to the power 1 times 5 raised to the power 1 times x raised to the power 2. Therefore, the LCM equals 3 raised to the power 2 times 5 raised to the power 1 times x raised to the power 2. Here, what you need to do is to multiply the terms that have the highest power, and that is what we are doing here. 3 raised to the power 2 times 5 raised to the power 1 times x raised to the power 2 equals 9 times 5 times x raised to the power 2, which is equal to 45x raised to the power 2. The next is factorization of binomials. The binomial expression has two algebraic terms. For instance, we have 2a minus 6ab. Two algebraic terms. 2a is an algebraic term, then 6ab algebraic terms. So the two of them now become algebraic terms. That's an example of a binomial. Another example is x plus 3y. We have x and we have 3y. So if you combine two of them, you have binomial. Remember, bi stands for 2. Then we have other examples. Example 4. Factorize a 10d minus 30e. B 3d squared e plus 5d squared. Solutions. A 10d minus 30e. There, just as we have learned HCF, you have to find the HCF of 10d minus 30e. So the HCF there is 10. We now use that 10 to do a very important thing. What is that? We have to use that 10 to divide each of the terms in the brackets. Let's go. 10d minus 30e equals 10. That 10 will come outside the bracket open. 10d divided by 10 minus 30e divided by 10. You close the bracket. You understand there that 10d divided by 10 will come down to give you d, while 30e divided by 10 will give you 3e. That's what we have down. Equals 10 bracket open d minus 3e bracket close. The next one, b 3d squared e plus 5d squared. The SCF of 3d squared e and 5d squared is d squared, because this is the highest common factor of the expression or of the terms. Therefore, 3d squared e plus 5d squared equals d squared, bracket open, just like what you did in A above, bracket open, 3d squared e divided by d squared, which is the HCF, plus 5d squared divided by d squared. If you divide that, you have equals d squared, bracket open, 3e, because 5d squared divided by d squared will give you 3d squared e divided by d squared will give you 3e, while 5d squared divided by d squared will give you 5. So you now have d squared, bracket open, 3e plus 5, bracket close. Before you is the exercise. You have to do the exercise and submit to me. I'm still online. Thank you very much.